Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how you can convert one form of concentration into another form of concentration by conversion factors. So let's get into this. So in this problem we're given concentrated HCl is 38.0% HCl by mass, and it has a density of 1.189 grams per milliliter at 20 degrees Celsius. So what is the molarity of HCl in this solution? So they give us the density, and they want us to convert to molarity. They want us to find the molarity. And they're also giving us the percent by mass of the HCl solution. So how can we get the molarity out of this? So remember that molarity, and I'll write it up here. So molarity is equal to moles of the solute over liters of solution. So we need a ratio. We need a ratio of moles of solute over liters of the solution. Okay, so if we could find the moles of the solute and then find liters of solution, we can then just divide that and we get the molarity. Okay. Another way we could do it is if we're given a ratio already, then we could convert the top and the bottom portions of the ratio to the units that we want. And that's what I'm going to do for you today. So they happen to give us the density here. So the density is 1.189 grams per milliliter. Okay, so that gives us a ratio. So let's write that out. So we're given, where is it? 1.189 grams, and this is grams of the HCl solution per 1 milliliter of the HCl solution. So we got a ratio here. So if we could convert the top part to moles of solute, and if we could convert the bottom part to liters of the solution, then we'll have our molarity. So let's go ahead and do that. So let's go ahead and convert the bottom part. So we have 1 milliliter of the HCl solution. We want liters of the solution. So all we need to do is convert milliliters to liters. Okay, so I have milliliters on the top. I'm going to have to put milliliters on, I'm sorry, said top. I have milliliters on the bottom here, milliliters of the HCl solution. So I want milliliters of the HCl solution on top here. So I know that 1 milliliter of HCl solution, 1 milliliter is equal to 1/1000th of a liter, or 10 to the negative 3 liters. So I'm going to put 1 milliliter of the HCl solution on top. And in here I have 10 to the negative 3 liters of the HCl solution on the bottom. So now the milliliters will cancel out, and then I have liters on the bottom, which is what I want. I want liters of solution, so now I have liters of the HCl solution on the bottom. So I'm done with the bottom part. I could have used 1,000 milliliters is equal to 1 liter. It works out the same. It's the same ratio. Okay, so now that I have liters of the HCl solution on the bottom, now I'm done with that. I'm going to go to the top. So I want to convert grams. I want to get this grams of HCl solution to moles of just HCl. So this percentage is going to be really useful. What does that percentage mean? Remember, anytime you're given a percentage in a problem, think conversion factor. So what does a percentage mean? It means out of 100 per cent. Cent means 100. Century, 100 years. So percent means out of 100. So if I'm given 38.0% of HCl by mass, what that is saying is that out of 100 units of my HCl solution, 38 of those units is going to be the mass of the HCl, right? So I can write it out this way. So out of 100%, 38% means that out of 100, say, grams, since we're getting grams, let's use grams. Out of 100 grams of the HCl solution, 38.0 grams of the solution is actual HCl. The rest of it is probably just water or whatever else is in there. But if it's a pure HCl solution, then the rest of it would be water. And then you got 38.0 grams of HCl. So now that we have this relationship between the grams of solution and the grams of HCl, we can then use that as a conversion factor. So here's how it works. Since I have grams of the HCl solution on top, I'm going to want grams of the HCl solution on the bottom. So here I have 100 grams of the HCl solution, so I'm going to put that here. 100 grams of HCl solution. And then 38.0 grams of the HCl is on top. So 38.0 grams of HCl on top. So now the grams of the HCl solution cancel out, and now I have grams of HCl on top. But I don't want grams, I want moles of the solute. My solute is HCl, so I need to use now molar mass of HCl to convert to moles. So let's do that. So I look up my moles, my molar mass of HCl, and it's 36.45. So I put 36.45 grams of HCl on the bottom and 1 mole of HCl on top. Now the grams of HCl cancel out, and now I have my moles of HCl on top. I have liters of the HCl solution on the bottom. I now have molarity. So now all I need to do is multiply across top, divide by the bottom, and I'll get molarity. And when I do that, I get 12,395. So I get 12.395 molar or moles per liter. And of course, I need to make sure I have the right number of sig figs. Remember that your answer should have the same number of sig figs as the least number of sig figs in the measurements you are multiplying and dividing. So here I have 4. This is exact, so I can ignore that. This has 3, and this has 4. So the least number is 3, so I need to cut it off at 3. So I have 1, 2, 3. So I cut it off there. This is a 9, so I round that to 4. So 12.4 molar is the molarity of this particular hydrochloric acid solution. I hope this was helpful. If you enjoyed this video, if this helped you in any way, then please, by all means, like the video. Hit that like button somewhere over here. Also, help me out. Support the channel. Subscribe to the channel. Hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if you have a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.